Correct? There's 14 things we have to go through. Yeah. So there's 14 things are there. Be careful of the mind. So integration of x raised to n.
So we're starting with
all this.
integration.
Yeah, starting integration, there are 14 parts to it.
So wow.
Correct? And we have to complete that. Fine. The first thing that you need to do is, and this is then your formula booklet, integral of x raised to n. Now remember, integration is antiderivative. It's the reverse of derivative. It's the reverse of derivative, correct? So, what you are doing in this case is, if you have integral of x raised to n dx. Now understand the symbol. Integral x raised to n, what is dx? With respect to x. They're telling you the variable.
Yeah.
So you're integrating with respect to x.
Yeah.
This is equal to x raised to n plus 1 upon n plus 1 plus c. When can you apply this formula? X is the base. X has to be in the numerator. So if I ask you to integrate, so 1, let's look at examples here only. So suppose if I ask you to integrate x cube dx. That's very simple.
X raised to 4 upon 4.
X raised to 4 upon 4 plus c. That's no problem at all. It can be a fraction. X raised to root x.
So
X raised to
3 over
X raised to
2
upon
by
4.
3x.
3 upon 2 plus c. Plus c. Acha, now why plus c?
Because
Because when you take the derivative constant became 0.
Yeah. So you don't
So the c is called the integrating constant.
Oh.
It's called the integrating constant because when you took the derivative, those constants disappeared, you know, the derivative. So therefore we put plus c in memory of those constants which are lost during the differentiation process.
Yeah.
Integral of 1 upon x cube.
That's actually so
Minus X
So you can't do it in the denominator.
So it's
minus 3 plus 1.
so it's
X raised to minus 2.
Minus 3 plus 1 minus 3 plus 1 plus c. So yeah.
X raised
So
to
minus
2.
half x square. You can write it like this also. Then when you simplify it using the law of indices. At the same time, you need to remember a few more things. You need to remember what is the integral of 1.
x.
Why?
Okay.
Because derivative of x was 1. So don't forget that. Integral of 1 is x. Okay. Now these are the few sums it's given over there. Now there can be sums framed in number of ways. They'll give you f dash x. You have to find fx.
So what
Means you have to integrate.
would 3a be 0?
One second. One second. We'll come to that. Listen. If your f dash is given to find fx, you integrate. Listen. First, pay attention to the question.
Yes.
Y dash is given to find y. You have to
Same
integrate.
thing, yeah.
Correct? Yeah. Same thing. It means dy by dx also means derivative. They'll say find the function or find y. You integrate.
Yeah.
So know that. Please know the symbols.
Yeah.
Okay. Which one are you saying?
3a, would that just be c?
3a. You think the derivative of something is 0. So what is my original function?
It has to be a number.
C. It has to be a number.
Yeah.
So you think your integration is antiderivative. Then all these are direct simple application. You have to integrate each of them. Now, what do you do when you have a coefficient? Like, what did you do when you had a coefficient for derivatives? Suppose you had 3x squared.
Need to get separately.
You kept the constant outside and to integral of the function. That's what we exactly do. Derivative of the function. So now find an expression for y. So y is equal to integral of dy by dx basically. Correct?
Yeah.
With the function. So y is equal to integral of 6x raised to minus 5 dx. Now what you do is you just keep 6 as a
So why
multiplier.
do you put dx at the end?
That's my variable. You're integrating with respect to x. Your variable is x. Like say you remember that when you did d by dt, there's a differentiator in respect to time. D by dx with respect to x. That's basically your x axis or time axis. So which variable you are differentiating with respect. Okay. So no need of writing all the steps. This is just the first sum that I'm showing you. 6 x raised to minus 5 plus 1 upon minus 5 plus 1 plus c, correct? So that's what? Minus 6 upon 4 x raised to minus 4 plus c is minus 3 over 2.
So you just leave it in that.
Yeah, you can leave it in that form also. You can leave it in this form also, no problem. They'll give you marks. But don't forget to get the thing in the numerator
When you integrate it.
when you integrate it. Then only that formula applies. Integration of sum of terms with coefficients. So suppose if you want to do integral of ax raised to n plus bx raised to n minus 1 plus c, yeah, something is given like this with respect to dx. So what will you do? Each term separately. So basically there's a rule which says that if you have integral of u plus v, if where u and v are two functions, you can do integral of u plus integral of v. If you have minus, like your derivative only, you do each separately basically. Achha, so you'll keep the constant outside, you'll integrate this. You'll keep b outside, you'll integrate this. Achha, by the way, there's no product rule, no quotient rule for integration. So you can integrate only when there's a sum or difference. If there's product, you know, HSC is having some 20 or 25 types of integration sums. So there are many types, methods of integrating, which you don't have. You have just basics. Means you do each term separately. Okay. Let's see with an example. Like this. Find an expression for y. So what will it be? What will y be? 3 upon 4.
X cube upon 3.
Keep 3 upon 4 as it is. Achha, what is derivative of x square?
X cube upon 3.
Plus 7 over 3.
Only x square upon 2.
Don't forget plus c.
You have to
Don't
add
forget
c
plus
twice though, no?
Ha, very good question. Do you have to add c twice? No, it won't matter.
Okay.
Because c1 plus c2 will become a c. Two constants will add up to give you another constant. So one c is enough. So this
Yes,
is
you don't need something with c2 and c1.
No, because he puts
if you integrate twice.
He puts C and someone asks why is it not?
Ha, because but there must be a sum. There must be a sum if you have a second order derivative to find y. So when you have a second order derivative, you first integrate, you'll get the first order derivative. For that you'll put c1. And then you again integrate, you'll get your y. So then your
It
c1
still
x.
becomes C again.
C1x. So you know the first c1 that you got will become c1x plus c2. Okay, yeah. So x cube upon 4, 1/4 x cube plus 7 over 6 x squared plus c. Very simple, sir. Very basic. Each term has to be done separately. What do?
You open it and then.
Yeah, you expand it. Why? Because there is no product rule, there is no quotient rule.
So can we try this?
Yeah, please try.
16A.
16a. See, that's very important. So what you do is, there's no product rule. There's no product rule, so you'll expand it. So x squared minus x minus 6 dx. So integral of x is x cube over 3 minus x squared over 2 minus 6x.
So can you also
Plus
use
C.
calculator and do this?
No. Calculator will be useful when you have the lower limit and the upper limit when you have definite integral.
Oh.
So when you have definite integral, that's the next part we'll be coming to in that. That time calculator will be useful because your calculator is not CAS.
Okay.
What is CAS? Computer algebraic system. So you get CAS calculators which does variables also like this.
No.
But which are not allowed in IB obviously.
Why?
Now this one 17a, very simple. What will you do?
Open it
You'll
again.
expand and do
I
each term.
got 3x cubed minus 1 over x.
Yeah, yeah. Correct. You expand it and do each term separately. Again, how would you do this?
You take both.
You
You
separate
separate
both upon
Separate.
You
Yeah,
do
separate. You
separate
separate them.
and then make
Yeah.
it
So
one.
4x. Do it. And don't forget what? To get the term in the numerator. Don't forget to get it in the numerator before applying that n plus 1 formula.
So I got
Yes.
minus 1 over x square plus 7 over 6x cube. The x cube will be there.
Correct.
Plus. So suppose you don't.
So what's going to happen in this case is, so suppose if I give you now kinematics, talking of kinematics, you have your displacement. What is velocity? Rate of change of displacement.
Derivative.
So derivative. Correct. So if my displacement is x, my velocity will be x dash or dx by dt.
Double is acceleration.
And acceleration is what?
Double derivative.
Rate of change of velocity. Rate of change of velocity. So this will be second order derivative. So if you are going from displacement to velocity to acceleration, you have to differentiate. But if you have to reverse the process,
You integrate.
you integrate.
But
That's
it will be change in velocity and change.
Yeah.
So wait, so this part is entirely about kinematics.
This is your kinematics. So you have to basically do derivative or integration. You don't have to do anything fantastic.
Okay.
So suppose if I give you, so question has been given, a is equal to 3t square minus 2t plus 4, correct? Find expression for velocity. Find expression for velocity, correct? Given that v is equal to 2 when t is equal to 1 or t is equal to 0. They've given you the initial velocity. Given that the initial velocity is 2. This is called the boundary condition, the initial conditions.
Oh, okay.
No, wait.
You integrate
Wait.
first.
Integrate
And then you substitute to get the C.
Yeah, that's
So if you don't do the C, you will be dropped. That will go. So your velocity will be the integral of the acceleration.
Yeah.
So integral of 3t square minus 2t plus 4. Now deliberately I put this 4 because there are some people
Wouldn't it just be 2 though?
minus, yeah, it will be 2 square upon 2 plus 4t plus c. Correct? This will be the velocity. Now you have to find c. So use the boundary condition. That's called the boundary conditions. So when velocity is 2, when t is 0. So all this becomes 0. So c is equal to 2. So what is the expression for velocity then? Now this is where if you don't have a habit of writing that plus c, you will miss out that plus 2 and you lose your marks ultimately. If I have a habit of writing plus c when you integrate, integrating constant has to be written. T0, yeah. So that means basically your c is, I'll give you a very simple direct sum right now. But the whole idea is that why do you need to put plus c? Now when you differentiate this, you will get that expression. So again, do this. This is quite simple. Sorry. So you could have got y is equal to x raised to 5 plus 5. Yeah, simple. I'm not doing it because you have to use the, put x as 0. You put x as 0, yeah. Plus c. Don't forget the plus c. So c is 5 basically. This one.
So you have to show steps,
Yeah, so if you work it out, what did you get? Y is equal to, you integrated. So what did you get? Tell me, just tell me.
X cube plus 2 over x
Plus 2 over x minus 4. So your C will come minus 4 when you substitute. Correct?
Yeah.
Now they can also give you like this.
Minus 4 over x
minus x cube plus
Minus 4 over x
minus x cube plus 10.
plus 10. So don't leave your answer plus as C, C ka value. That's not what you've been asked for.
So you lose for 1 mark though.
Yeah. Now this is applied in a context. So let's see, let me work it out. So you've been given the rate. Rate means it's a derivative.
Oh, so no.
The rate of growth is 0.5. So you have this equation.
It's 3, it's 3.
So this is
You have to integrate and answer.
time is t, correct? 2. So 0.4 is equal to 2k. So k is equal to 0.2, correct?
Yeah.
So that means my dm by dt becomes 0.2t plus 0.1.
So C is 0, right?
Yeah.
That's the value of k for part A. Now part B, you have to find out m. Now they've given you the initial, the boundary conditions have been given. So when initially means when your time is 0, mass is negligible, means your m is 0, and you want to find a mass after 5 weeks. So what will you do is first you will integrate this. So that's your 0.2 t square by 2 plus 0.1 t plus c. Correct? Now use the initial conditions. So mass is 0 when time is 0. Correct?
2.5 plus 1.
So 0. C 0.
It's this now.
So now what is it? So mass is equal to how much? 0.1 t square plus 1.1 t.
And then you substitute.
Now you want 5 weeks. Now acha, one more thing. Please check. 5 weeks, listen. 5 weeks.
Whether he is measured.
Whether this is also in weeks.
So what?
He is measured. So it's like
Otherwise again you have to convert. So 2.5 plus 0.5. So 3. Correct? 3 what? 3 kg. Again, they won't cut marks from not writing units. But you understand this?
Yeah.
So initially means when your time is 0. Don't forget that. Definite integration.
That's all we have done.
No. That's the related thing. Definite integral using GDC and by hand. Now what is definite integral? Suppose if I give you integral lower limit and upper limit 1 to 2 of 3x square dx.
So what does the limit mean?
Okay, now what does the limit mean? Now pay attention. Wait. Calculator, obviously you have to fill out that template. But what to do by hand? Because if they give you certain variables, you'll need to know the technique. So what you need to do is, you integrate first. 3 x cube upon 3. Put a box bracket. Yeah, this is just x cube. Put upper limit, lower limit.
Oh, when it's x cube.
Now what you do is, upper limit minus the lower limit. So 8 minus 1, which is 7. Now here you are not putting plus c.
Why?
Why? Because it will anyway cancel out.
Yeah.
If you put by mistake also it will cancel out. So you integrate and then substitute upper limit minus lower limit. On your calculator, obviously you will just fill the template.
So, but even if they give you, you can use the solid equation if they give you.
So it becomes really weird. I'm not.
No, like I figured out.
Yeah, in class we were going on different answers.
Yeah.
No.
This definite integral gives you what? So if you have a curve, my function is 3x square. This is x, this is y. This is 1. This is x is 2. It is giving me the area between the curve and the x-axis.
That's the mix.
Yeah, it's giving me the area between the curve and the.
Yeah.
And that's what we are doing. Okay. Okay, next. Using GDC, so obviously you know what to do. So just use GDC and get this term. Some people are only GDC specialist. When you integrate this, and if you use your graph, there are two answers that you get at the bottom. So the first answer is your integral. What's my integral?
0.2625.
Minus 0.625. My integral I am calling it. Now if you look at the area, what is happening is, you're getting this and you're getting this, because your 1 is coming here and your 2 is coming here. The second answer, what's my second answer?
1.265.
1.265, that's your area.
That's the area.
That's the area.
Why?
Now what is happening is, listen, I'll tell you. If you integrate between 1 and this point of intersection, your answer will come negative. Because the area is below.
Yeah.
And if you integrate this, your answer will come positive.
Yeah.
So if I ask you the integral,
Yeah.
it will be minus a plus b. Correct? But if I ask you the area, what will it be?
1.
Mod of minus a means you basically it's giving you the absolute values.
Yeah.
Now this is what the next thing is. If this was the velocity function, the integral will give you the displacement between 1 and 2 seconds.
Yeah.
And this will give you the distance traveled.
Total distance.
Total distance traveled.
Yeah, area under it.
Are you understanding what I'm trying to say?
Yeah,
So
yeah.
let me just explain this to you. Suppose a car starts from here, travels 3 meters, travels back 2 meters. What is the distance traveled? 5. Displacement? What is the displacement? 1. So remember that displacement is your signed area. So displacement is what we call signed area. Means signed means you take the sign of that area and put it. Like so this was negative, no? Minus a plus b.
Yeah.
You take it with the sign. You cannot ignore the sign because displacement is a vector quantity.
Yeah.
And what's your distance traveled? Absolute value.
Yeah. So technically the area is this.
Yeah. So area, if they ask you area, this is your answer for area. If they ask you. But if they ask you integral, this is the integral.
So the integral you don't do actually.
Integral you don't do actually.
Is that why U and V come in the physics equations? Like,
Yeah. Okay. Chalo. Find the area of the shaded region. Actually, by the way, when you're doing this on your calculator and paper, make it a point you write the expression. You write area 1 to 4, correct? 1 plus 2 upon x square dx.
so if you wanted to find this without using the calculation, is that like,
I told you, no, I taught you. No?
no, so the area, like using
Yeah.
So you can integrate this one. You can do it by hand. You can do it by hand, no? You can integrate and put upper limit minus lower limit.
So saying not found, I got the integral as 4.5, but not giving me the area.
No, because it's the same.
Oh.
The whole graph is above, no? You don't have one part below, one part above.
But how do you do the integral?
Just don't do mixed, do FDR.
But you can use a run mode, no? Use the run matrix and do it. Use the run matrix.
Give you area in case there's an area.
In case below those.
I'll tell you how to do that also.
4.5.
I'll tell you how to do that.
Absolute value of the function.
Yeah.
Correct. You do absolute value of the function if you want area.
But that's one manual typing.
Yeah.
I'm just going to do graph.
You understood this?
Yeah.
Oh, it took me so long to realize that can't.
You know how to do this, huh? Quickly. Find the area enclosed between the x-axis and the graph. You can use your graph and you get your intersection between the zeros and your area will be how much? 10.7.
So only I say y-axis and that.
It will come. Yes. Your prayers will be answered. So G sol and what did you get? 5 point? What is it?
You do intersect
2.5 and
6.25. Now to find the area of the shaded part.
Yeah, so
One of the way of doing it is obviously you graph it. You graph both of them. So you enter the equation 5x minus x square. Pay attention if you know it. 5x upon 2.
For this, you take from 0 to 2.5.
Yeah. But that's
Correct?
this under-
Now listen.
That's what you mean.
G solve.
Then why
G
do you
solve.
need the
I got
rest of
something
it?
else.
Look. Integrate.
You just do
Integrate. Now see, I can also use intersection. So if I use intersection, it will take from this point of intersection, go right to this point of intersection, enter.
Yeah, and then you do the remaining of it.
That's what I did.
That's what I thought, yeah.
So it will give you the answer. Why is it not coming? It has to come. Acha, I didn't enter. Sorry.
Enter the 0.
Okay, I didn't enter. So what you have to do is listen. Intersection.
2.5 to 5.
G solve, integrate.
10.41
Intersection.
plus 7.81.
So it gives you this the first one. No, listen. You enter.
18.23.
Huh? Then you go to the second one. Enter. So this area is how much? 2.60.
That's what I thought. Yeah.
2.604. You're getting
Then I got
this area.
20.8 rest of that.
2.
You don't have to subtract anything.
2.6.
That's how I got
20.83 minus.
This is this area, white area. Now what is the total area? So what I can do is I can deselect this. I can deselect this. Okay. G solve integral, and you can say take root. So it will take this root. This root. You will get the total area with 20.83.
So
20 point.
So there's an easier way to do this.
I mean different way. May not be easy. Different.
I did it easier way. So I did it. So that first part was the same. I did till 2.5.
Perfect.
And the rest of it,
That's another way.
2.5
Correct.
to 5.
Correct. So what you can do is, listen, now this is 2.5. Now for this one, A1, so total area will be A1 plus A2.
Yeah, that's what I did.
So A1 is from 0 to 2.5. Now this is below the line.
That's why I tried to do it.
5x upon 2. This is below the line.
Yeah.
This is below the line. Remember, it will always give the area between the graph and the x-axis. Plus, this is from 2.5 to 5, correct? Of A2. A2 is the curve. Then you can type this on your calculator and get the answer. What's your answer?
18.23.
18.2. Any method you do, your answer will be the same. Find the area of the shaded part. Now pay attention, children. Now pay attention. What you can do is, whenever you get this upper and lower, you simply put in the absolute value, numeric, absolute, type in the function.
Well, then put the whole minus 1.
Yeah, and just put a -1 to this, straight. Just put in the absolute value. That's it. So, how will this become a kinematic question?
This will ask you for this is distance.
This is asking you distance. And if they ask you displacement,
Then you don't put the answer.
but what kind of graph though should this be? Velocity time graph. Huh?
Yeah.
Achha, obviously, if it's a time graph, the time can't be negative. That's another story. Okay, if you do this.
So you don't know what area I'm taking. I wouldn't do this.
Automatically, you know.
Graph the scene.
So
Yeah,
1.63. So what is their calculator doing is, it's flipping this area.
Yeah.
It's just reflecting this and finding the total from this.
Yeah.
That's what it's doing. Absolute value means you just flip the graph. Okay. So if this is a velocity time graph, this will give you the distance traveled.
Yeah.
And if you do not put the absolute value, it will give you what? The displacement.
Yeah.
Do this. So first thing you can do is write your step and you write down the point of intersection. What is the point of intersection? 5 by 4. Achha, by the way, your calculator should be in radian mode. Huh?
Yeah.
So that means your first one is your sine graph.
What's the
So your A1 would be what, from 0 to pi by 4. 0 to pi by 4 sin x. Please write this, huh? Write like this.
0.5 is.
Yeah.
What's your first part answer?
A1 equals
0.4142.
4142.
I did a different way. I did the whole, like that area, that small area, and then I took the whole area.
Yeah, but because this is a different function and this is a different function.
Yeah, no, I took that area.
Okay, and then you found the whole
And I got the
constant.
whole.
So pi by 4, pi by 2.
This, not this.
You find these two and add up. That's what I would do.
No, I didn't.
That's
do
what
that.
I did.
I would do this. So what's your first part? 0 point, what is it?
So it was some 0.292.
Yeah, 0.29.
0.29
was the first.
26. And what is the next one? 0.2932.
0.2932.
You add them up. So your total area would be. Are you getting the same answer? 0.585?
Yeah, but I did this. I did this. And then I said.
Acha, okay. Okay, fine. You can do that as well. You understood? So any approach is fine, but you should know what's happening. But you write an expression. That's important, so that you get, if you make some mistake. Now, this is another application. Okay, the amount of material accumulated if we know the rate of accumulation. So this is initially what is there. This is the initial volume. Suppose you are doing volume versus time.
This is not motion.
Yes, it's in your portion. Okay, and this is the rate.
I have no recollection of this.
And this is your time from B to A.
Yeah.
You have to just apply the formula. It's quite
This
intuitive.
is not 5.1 to 5.13.
Yeah, everything is there.
What?
But it's nothing like this. Do this. Read this up. This is where you have to
So
apply
what's the
that.
formula?
We go back to home.
How do you know K is 1?
With 9 equals 5 plus 1.
Oh yeah.
Correct. Very good. So the rate of water flow is given.
Yeah.
Rate means, so that means your dV by dt is given to be 5 plus
Oh, okay.
K into T square. Now the rate is 9 liters per minute after 2 minutes.
Yeah.
So after 2 minutes, so rate is 9 and after 2 minutes.
Yeah.
So K is equal to 1. Okay. So that means what is the rate become? dV by dt is equal to 5 plus T square. Now how much water is filtered in the first 2 minutes? So volume of water will be the integral of 5 plus T square dt.
12.6.
From 0 to how much? First 2 minutes. Are you following? So this is the rate is given, but there is no initial volume. So it's 0 plus that. 12.67, 12.7. Are you following? Suppose if they get already 2 liters was there.
Yeah.
So you'll do 2 plus
We don't
that.
need this formula. That's what I was
So that's the formula, no? This is the initial and this is when they give you the rate.
Oh, we broke up the
Why is it B and A?
So that's your initial time. That's your initial time and you find your time.
Why?
Why
Why
because
is it B and A written?
any timeline can be like between 1 minute and 3 minutes.
So one is A and B is also.
Yeah.
That's how it's given in the textbook, but it's fine. It can be anything. See next one now.
So is it the other working now?
Hmm?
So what is the application?
So for the first minute of the activity, the rate at which so dV by dt, you can see the rate at which the volume of the paint is getting this, or mass, so dm by dt, directly proportional to the time it has been on, directly proportional to time. So dm by dt is equal to kt, where k is a constant of proportionality. Now they have given you 20 grams per second, that's the rate, correct? After 10 seconds, so k is equal to 2. That means your dm by dt is equal to what? 2t, correct?
Yeah.
Then what is asked? What is the amount of paint at the first minute of the activity? So
0 to 60.
0 to 60 of this rate, correct? So what's your answer coming to? 3 grams. A model suggests that sand falls through a timer at a rate of, so dm by dt is equal to 100 over t cube, correct?
That is correct.
Time in seconds after it started. when t is equal to 1, there are already 10 grams in the base of the timer. Correct? 10 grams of sand in the base of the timer. Part A, find the amount of sand in the base 5 seconds after it was started.
Yeah, 58.
So what is the amount of sand be?
10 plus.
So 10 is already there. Plus 1 to 5.
Why is 10 already? Shouldn't it?
It's given over there, no?
When t is equal to 0, there's 0 grams of sand.
When t is equal to
Oh,
1.
because you're taking 1 to 5. Oh,
I'm taking 1 to 5.
Go 16. I thought you were taking 0 to 5.
I'm not taking 0 to 5 because because already 10 is there, so 1 to 5. That's what
But
they
if you
want.
take 0 to 5, why do you not get this?
Because they've given you this. I mean, they should have the timer started at
That's
1.
why I was confused.
The timer started at 1. They should mention that.
They should say find the amount of sun in the base 1
Yeah.
between 1 to 5.
No, but they're saying that t is the time in seconds after it was started.
Yeah. It doesn't say it was started at 1 second.
After it was started, yeah.
It doesn't say it was started at 1 second anywhere. That's why I was confused.
What is the eventual
It could have
answer?
started at 0.
60.
Yeah, it can start at 0. But then your answer would be different.
No,
Yeah.
like.
That your answer.
Yeah, it's 60 grams.
How much did you get this?
60
And they give
grams.
you
60.
You do that and then
Wait,
You
you
know,
got-
I
No. So this was 58. This was 58.
So basically,
58.
the initial volume doesn't have to be when time is equal to 0, right?
Wait,
be
wait.
And it can be anything. Yeah.
That's what I was happy when
Yeah, no, not necessarily. Initial volume
Yeah,
can.
that's what
Initial volume cannot
the
necessarily.
question is.
Yeah, I mean it's not well worded.
that's not and that's a key.
Okay. See, do this.
So what was the flaw with that model?
Oh,
For the-
the
same.
The rate is the same, or you're starting with some initial volume inside.
They always put OTTW.
What does that mean?
I mean, correct operation or something.
So first of all, f dash x is given. First you find out fx.
Oh.
So f dash x will be integral of.
You forgot plus C.
Correct. So integral of x square. That x cube upon 3 plus c. Now if you forget plus c again you will go wrong. That's what has an habit of doing
Yeah,
that.
I didn't know what. I was like, I have everything. Why am I equating?
Yeah, I was wondering why the
So 4 is equal to c.
I was like, what's the point of that?
So therefore fx is equal to x cube over 3 plus 4. Therefore the integral from 0 to 3 you put in your calculator. You
So I
simply
was
put
doing the same thing as last time where you add 4 from the start.
then how much is it?
18.7.
Yeah.
18.75. Acha.
So why
Now,
don't you add 4 at the
or
start?
suppose if we can you do 4 plus integral from 0 to 3?
No.
0 because
Zero,
f
three.
0.
No, sorry, it doesn't work.
But we don't know the integral, na? We don't know the function.
But it doesn't work.
Yeah, because we don't know the
You
function.
get 13 if you do that.
You got 10. 10 or something.
No, I didn't know.
You need the function.
I
You
used
don't
the-
know
I
the
used
function.
the-
Alright, then you don't have to take the plus c
Yeah.
because that plus 4 is there.
So there's no way to get the derivative on the calculator, right?
No, algebraically you won't get. You'll get definite.
Oh my God.
Chalo, next.
So that.
But the point is that people, so if your integral is this, listen, so you differentiate both the sides.
Yeah.
So when you differentiate both the sides,
Why
by
do you
df,
differentiate both the sides? You differentiate the function.
we don't know the function.
No, differentiate whatever it is.
This is the integral of the function. So your derivative and integral will cancel each other. They are like doing undoing. They are inverses of each other. So
That's what I was doing.
so then you differentiate it basically. So that's 4x cube is what?
You take C.
It's damn weird to think about you differentiating an integral.
So 4x cube
12x square.
plus 4 upon x square. So 4x raised to minus 2
If you differentiate.
plus 4c. So what is the 4 3s are 12x square minus 8x raised to minus 3 plus
Plus 0.
0. Derivative constant is 0. Okay.
So break 3 minutes.
Okay. Now let's have a short break.
11.
Okay. Now pay attention, please. integral of sine x, cos x, 1 over cos square x, e raised to x and 1 over x. So the same thing will apply